So we're going to be writing equations for exponential growth and decay. And let me get my screen share going here. What's going on? All right, so we did get the board fixed. I can write on this, and hopefully we're all set with that. So equations for exponential growth and decay look a little bit like this, where remember, A is the initial value. So when I've got a number out in front, then I can consider this the initial value. And my handwriting is going to have to take a little bit of time to get used to this new board, so I apologize. And then when we look at the number inside, so the growth or decay, the increase, the multiplying factor, we always think of that as a number compared to 1. And then how much bigger or smaller than it is tells us how much it's increased and how much it's decreased. So one whole thing is always 100%. Now, 1.20 would be an increase because this number is greater than 1, which we've talked about. But how much bigger? Well, it's an increase of 0.2. Now, with decimals, you always have to move it 2 times to make it a percent. So we add in a 0, and we consider this 20%. So that's a 20% increase when we have a number like 1.2, because the 1 is the original, the 100%. Now the 75% is a decrease because this number is less than 1. Now how much less than 1 is it? Quick little subtraction problem here. That is a 75. Apologies. Would be 0.25. Okay? So because it has been decreased by 0.25, that's really a decrease of 25%. All right? So important to realize that we are trying to subtract when it's less than 1, but then maybe subtract again when it's greater than 1 to find how much it is away from just good old-fashioned 1. Well, I hope that we're doing well out there, and if you have any questions, please let me know by typing them into the chat publicly or privately, or unmuting yourself. Let's take a look at a couple of exponential equations that have already been written for us and see if we can come up with the goods. We have a bank account that has T years. The balance of it, that is, after T years it was opened, given by the equation below. And we want to find the initial balance. Again, the initial value is that A term. So the number that comes first, we started with $500 in that bank account. Now, is it increasing or decreasing? Well, banks, like Mrs. Robarge said in the earlier discussion about winning the lottery, they're going to give you money just for having your money in the bank. So this 1.02 is an increase. How much of an increase is it? Again, subtract the 1 out of it to see that this is 0.02. Well, move that decimal 2 times to see that it's a 2%, and since it was above 1, an increase. Again, my penmanship not very good on this board yet, so apologies. So a 2% increase because it's over 1 by those 2 hundredths, but we have to change it to a decimal by moving the decimal place twice. Now, what is the balance after 10 years? So how can we use that? Well, we're going to go back to our function and insert 10 for t, because I'm assuming they're using t for time. So wherever I see a t, here and here, I'm going to put in 10 years. So that's 500 times 1.02, and I'm going to do that to the 10th power. Now, the best way to do this is to use a see it, but just not the V10 part. So we're going to do 500, 500, parentheses, we've got them. So parenthesis, and then we're going to put in the 1.02, close the parenthesis up. How do we make an exponent that large? Use the up arrow key and 10. So there you have it. But for some reason, I put it into the y equals, which I didn't want to do, so second quit. All right, let's just use the regular old screen, Mr. Petrie, huh? How about that? 500. Good practice here. You can see me do it twice. Parenthesis, decimal point, 0, 2, parenthesis, up arrow, and we want to do it for 10 years. And just putting $500 in the bank for 10 years at a 2% interest rate, you're going to be up to $609, and let's round it to the nearest cent, 50 cents, because when I have 49 cents with a 7 behind it, I am going to round that up. So you've made almost $109 just by putting your money in the bank. And that's why it's smart, if you get a large sum of money, just live off the interest. And there you have it, $609.50. Any questions, please keep them coming into the chats, and we're going to move on to the next question. Here we have a car that has t years, after it was purchased, given by the equation. So we've got the value of the car, let's maybe assume V for value, and then the time t in parentheses, just kind of giving us the information about the function that we need, 30,000 times 8,500ths to the t power. So a car, the worst investment you could ever possibly purchase, because it always depreciates in value. Very rarely will a car ever get you some money, more money out than you ever put into it, especially in this area when we salt and sand our roads like we do. So the value of is the value of this increasing or decreasing? I kind of gave it away. It is a decreasing function, but how can we tell? This number right here, 0.85, is less than 1. All right, so because it's less than 1, let's find out how much less than 1 it is. So we're going to subtract 1 minus 85 hundredths, and this will end up with 15 hundredths. So what percent is that? Remember, percents are numbers based out of 100, so you have to move the decimal twice. So it would be just plain old 15%. Now, how much has this vehicle gone down? All right, how much have we lost from the original $30,000 that we paid for it after just 5 years? Let's use 5 for t, and then substitute in the 5 for the exponent. Okay, so good old-fashioned 5 right there. After that, let's go to the calculator. Going to clear out what I previously had. I bought this car for 30 grand. It's depreciating at 0.85. So that's how much remains. That's how much value remains. We're actually losing 15 hundredths every year. Now, after 5 years, after picking it up and being so excited about a new vehicle, that vehicle at this depreciation rate is only worth $13,311 and maybe 16 cents. So obviously that's maybe a little drastic, a little more than the real value of a car, but hey, maybe you got in an accident, maybe there was some damage done to it, so you've lost quite a bit of value in that vehicle. So again, that $30,000 vehicle is now only worth $13,311.16. Whenever we're dealing with money, let's round it to the nearest cent. All right? So just going to let you finish that up. If you ever felt like you got behind or I went too fast, there is a completed copy of the notes in the module. We got just the second half of this done to do. Sorry, second page to do. And again, once you complete the notes, this is the assignment for today. There is nothing else left to do. So let's get into it, and I'm going to ask a quick little poll question here. The population of bacteria can be modeled by the equation below. Want to see some active participants. We want to know what the initial population is. So initial population, what do you think? Is it the 1,000? Is it the 0.98? Or is it the 98? 1,000 was the initial value, and the decrease because it's less than 1. Now, what percent is it decreasing? Again, think of this as how much less than 1 is it? So I do a quick little subtraction problem and see that it's 0.02, but you move it twice to make it a percent, so it's really 2%. Now, what is the actual population after 12 years? These bacteria studies are really done using exponential functions quite often, so this is really nothing new. So here we go and use 12 for the number of years. Again, I'll show you how to use this with your calculator. If you don't have a calculator, you could use something on the internet, obviously, to help you with these calculations. So 1,000 bacteria is what we started with. It is 98 hundredths that remain, so a 2% decrease, and it's being done for 12 years. Oop, just got 2 there, 12. So, calculator says 784.61. Since it's bacteria, we don't need to maybe round to the nearest hundredth. We can maybe just round to the nearest object. So 784 with a 7 behind it. Remember that this would mean we would have to, can I write on this screen? No. That we would have to round up because it's 5 or higher. So 785. How's that sound? After 12 years, the number of bacteria is 785. Just a couple left here, folks, so stay with me. We've got to write an equation. So let's see if we can come up with the whole thing. Now remember that an exponential equation is y equals a times b to the x power. That's what we talked about in class last time. So we got to come up with all these pieces. To model the value of an antique chair. Is anybody into antiques? Anybody into collectibles? These are things that usually increase in value or hold their value. So if it was purchased for $250 and increases in a value of 3% per year, what's the equation? Well, the y is going to stay, all right, that'll stay the same. The initial value is the $250. That's the price of the antique chair. And because it's increasing, we got to think of it as being 1 plus that 3%. And we want to do that for X number of years. Well, how can we add that together? We keep the 1. We want to change the 3% to a decimal, 0.03. And 0.03 plus 1 is good old-fashioned 1.03. Okay, so that's just the 3% increase for that antique chair. Now, what's the value of the chair if it's going to increase at 3% for 15 years? Well, let's simply just substitute in 15 for the exponent. Once you've got that, the only thing you have left to do is put it into your calculator. So I'm going to clear out some of this because it's looking pretty crazy. And that chair started off at a $250 value. It increased by 3%, so that's 1.03. And I want to see the value of that chair in 15 years. Is it worth holding on to, or should I sell it? So in 15 years, how about $389? What's that, Andrew? Awesome. Ditto. Or jinx. Double jinx. All right. $389.49 is his money, so let's round to the nearest cent. So how about 49 cents? So $389.49. Excellent. Double jinx. All right, last one, and we're done. We have to write an equation to represent the value of a car that was purchased for $15,000 and depreciates at 10% per year. Let's remember that this is written in that y equals initial value A times the growth or decay rate to the x power. So that 15,000 was in fact the A value. That's how much we started with, so 15 grand. And because this was a depreciation of 10%, then this is going to be 1 minus 10%. Let me get rid of that. And then I got to move this decimal 2 times, so 1 minus 0.1. Whew. struggling with this board, and of course I can't erase because I don't have an eraser, so that's going to be one thing that's challenging. But 0.9, yes. So 0.9 is how much how much will remain. We're going down by 10%. And so once we have the equation, we want to find the value of this car after 3 years. So 15,000 times 0.9 to the third power. And guess